Okay, so for this first one, 3x minus y, x minus 4y. You all right with that? How many people got that? Okay. Yeah? All right. So that one there, again, essentially all you have to do is ignore that second one, that y. Ignore it. So then just factor this guy. Factor the 3x squared minus 13x plus 4. So you can factor that. You have to use your regular rules for if a does not equal 1. Okay? Go ahead and do that. And then just plug the y back in at the end. You end up with 3x minus 1 and x minus 4. Tag a y onto the second term in each parenthesis. All right? We go with that. Yeah. All right. Move on to the next one. Difference of two squares. Now, sometimes you're not always going to have your trinomials. Trinomials have the 3 terms, right? This one here only has 2 terms. Now, in this case, this is just a special case here, if both terms are squares. Okay? Now, notice, this is the difference of 2 squares. It's not just 2 squares. So if there's a plus in between, can I do it?
Yes.
No. I cannot do it if there's a plus in between. Only if it's a subtraction. So, there's your rule for it. A squared minus b squared. If it's in that form, it turns into a plus b, a minus b. So what you really need to do, just square root each term, and then plug in your a and b. So I have this example here of 81x squared minus 49. First off, 2 things you need to check. 1, is both terms a perfect square?
Yes.
Yes. Second thing, is there a subtraction in the middle?
Yes.
Yes, so we're in good shape. What's the square root of 81x squared?
9x.
Be 9x. What is the square root of 49? 7. Okay, now those 2 are going to be my a and b terms now. All right? That's my a and b, 9x and 7. So just plug it into a plus b, a minus b. So 9x plus 7. 9x minus 7. Boom. Done. Questions on that one? Really quick. Okay. Give you 20 seconds to do that on your own. Hoover, what'd you get?
Which one? 6a plus 4, 6a minus 4.
6a plus 4, 6a minus 4. Do we agree? Yeah, I like that. All right, that's a pretty nice little one to have, just in case. But again, make sure it fits into that form that we just talked about. Next one, repeated factorization. Okay, if we have something of a higher order, in this case we have something to the 4th power. We can't do the difference of 2 squares, can we? Okay, it's no longer a square on that left-handed side. What we can do, though, is by repeated factorization, we can try to break it into squares, because we know how to work with squares. Now, if I look at this guy, can I rewrite this as x squared squared? Doesn't that work? And does 81 square root? Yeah, what's its square root to? 9. So wouldn't that be 9 squared? Right? Now, if I look at this, is that a perfect square? Is this a perfect square? So now I have difference of 2 squares, don't I? All right, because I have a square with a minus in between. So this turns in difference of 2 squares. So exactly what I did before, this guy and this guy. That's my a and b. X squared plus 3, or sorry, plus 9. And x squared minus 9. Because the x squared and the 9 would be the square root of the original to the 4th. Because of the square and the square. Alright, so I just was able just to rewrite it as squares and then plug those in. Questions on those? All right, 7. We got what's called a perfect square trinomial. These ones are a little bit trickier than like a difference of two squares because there's one extra thing you have to worry about. You have to worry about that 2ab term. So I'm going to write this down. This is just a really simple one. 6x squared, or x squared plus 6x plus 9. Okay? I think we could easily see that this would be 3 and 3. Agreed? But when I look at this, look at your a and c terms. Is that guy a perfect square? Yes. Is this guy a perfect square? Yeah. So let's square root them both. This guy would be x, correct? This guy would be 3. Now if I multiply 3 times x, what do I get?
3x.
Multiply it by 2, what do you get?
6x.
Is that the middle term?
Yeah.
So it fits this rule. Okay? So and then in this case, I'd have x plus 3, 20 squared. So first thing you have to do, a term is a perfect square, c term is a perfect square. Square root it to see what your roots would be. Multiply them together times 2 and check it. Alright, let's do another one. So I have 4x squared plus 12x plus 9. Is my a term a perfect square?
Yes.
Yes, what would it be?
2x.
2x. Is my c term a perfect square?
Yes.
Yes. And that's a 3, right? What's 3 times 2x? 6x times 2? 12x, is that right? Yeah, so I'm in good shape. 2x plus 3. And you have, it feels like if you got the perfect square at the beginning and the end, that you're in good shape. A lot of times people make this mistake of, all right, x squared. So this problem here, just pretend that this is a 16 in the middle as my b term. They go, okay, perfect square, boom, factor it. That don't work, does it?
No.
Okay, you have to do that. Multiply them together times 2. Check it with the b term. Yeah.
What about the sides? What do they do?
Signs would be the same as like the other ones, traditional form.
So if it was a plus and a minus, it wouldn't be a perfect square.
There you go. The only difference. Okay? It's minus minus, it wouldn't fit this rule. Okay? Your c term has to be positive. Remember, positive c term is either plus plus or minus minus. They have to be exactly the same for this rule to work. Alright? So, I'll put one more up here for you guys to try. And we'll move on. Let's go 9a squared minus 30ab plus 25b squared. Same thing as before. It's got 2 terms. Basically ignore the second letter until the end. Then plug it back in. Give you a minute or two to try that one. Boone, you got it for us? 3a minus 5b squared. We agree?
Yeah.
Yep, I agree with you too. Okay, perfect square. This would be 3a. Perfect square. This would be 5. We can just put the b in too if you want. Okay, 3a times 5 is 15a times 2 is 30. That fits there. We're in good shape. Just subtraction here, so we have to put it there. All right. All right. 8. Sum and difference of 2 cubes. This is very similar to this other one. All right. In this case, you're going to have 2 terms that are perfect cubes. If that's the case, you plug it into this formula. There is one spot here that everyone messes up every single time, it feels like. And we'll take a look at it. But, so there's the rules. If you're adding them, then you have a plus b, a squared minus ab plus b squared. And if you're subtracting them, we have the a minus b, then all pluses. A lot of people mess this up. If they have a plus b, they try to make these all pluses. Okay, make sure that this is the minus. So with a plus, the minus is here. With a minus, the minus is out front, and everything else is plus. Okay, just be careful on those. On the formulas where those signs are at. So let's just look at a real basic one. If I have x cubed plus 8. Alright, are those both perfect cubes?
Yeah.
Yes. What's cube root of x to the third? X. Cube root of 8. 2. That becomes my a term and my b term. Now, it's a plus, so I'm looking at the top one. So I have a plus b, so x plus 2. Now, my a term squared. What's a squared going to be?
X squared.
X squared. Then I have minus ab. So I have minus, multiply the two together, 2x, plus b squared. So what's my b term?
2.
2, and then squared would be 4. A lot of times people forget that one and forget to square it. Right? You good?
Same opposite.
All right, let's do one more of these. We'll do it together. It'll be fun. All right, 125x to the third plus 216. Are those two terms perfect squares?
Yeah, sure.
Yes.
Yeah.
Most likely.
I wouldn't write it here if it wasn't, right? All right, what's the cube root of 125? 5. That's 5x. All right, what's the cube root of 216?
6.
6. Okay? Now, it's addition. Okay, so I'm looking at the first one yet again. A plus b. 5x plus 6. Now, right here's a big mistake. A squared. I have to square both of these. A lot of times people will put 5x squared. I have to square them both. What's 5 squared?
25.
25 x squared. Now the second term, I have to have minus ab. So what's 5x times 6?
30x.
30x. Plus b squared. 6 squared is
36.
36. Okay? But make sure when you plug in the a term and the b term, if there's a variable with there, in this case, the root of the first term was 5x, make sure we square the 5 and square the x. With me?
Yeah.
Do we need an example of that on your own? Or you guys good with that? Let's just plug it into the formula. Okay? All right. Last one. This is just kind of an overall thing. All right? If we want to factor a polynomial, you want to pull out the GCF if one exists, determine if terms factor if possible, and check to see if you can break them down even more. Okay? We're going to look at a couple more here. You got room on the back too if need be, right? I'm going to look at, I got 4 problems. Okay, I'm going to do 2 different styles and then give you one of each style to try. Alright, so first one. Let's look at this guy. I'm going to factor 2x to the third plus 8x squared plus 8x. Alright, now we can use anything in our toolbox so far. Alright, we just went through 8 different types of factoring that we can do. We got all the options. Now I look at this thing right away, and this is a trinomial. But I see a variable with every one. Agreed? First thing that comes to mind for me is I got to get some variables out. At least get a whole number in there somewhere. So what can I pull out of this? I can pull out a 2x. Yeah, pull a 2x out of everything. So 2x, that leaves me with what? X squared plus 4x plus 4. Good? Now, 2x is sitting out front. I just want to worry about that trinomial inside. Now, looking at that guy, looks like it'd be a perfect square trinomial, doesn't it? So x squared is a perfect square. 4 is a perfect square. All right. What's square root of x squared?
X.
Square root of 4?
2.
2. 2 times x is 2x times 2 is
4x.
4x, so I'm still good there. So I have 2x. What goes in parentheses then?
X plus 2.
X plus 2.
Squared.
That's squared. Quantity squared. Correct. Guys all right with that one? All right. Let's look at one more here. And then I'm going to give you 2 to try, then we're done. It's x squared minus 25a squared plus 8x plus 16. Alright. I don't love that one, do you?
No.
What's the one term in there that you look at and go, what the heck's this even doing?
Negative 28.
That 25a squared, right? Let's do this. Let's rewrite it. So let's put him at the end. X squared plus 8x plus 16 minus 25a squared. I didn't change the thing at all, did I? I just rewrote it. All right, that's perfectly legal to do. Now, that guy looks a lot better, doesn't it? Let's factor this first 3. That's a perfect square trinomial, isn't it? That would be x plus 4 quantity squared. You guys all right with that? Now, that 25a squared, there's nothing else to factor with it, but what type of term is it?
At this time, a lunch can go to lunch. All
Give me 30 seconds here. Okay?
Again, a lunch can go to lunch. Everyone else can go to period 4.
All right, so this one here, that's a perfect square at the end. All right? So I can go minus, let's make it 5a quantity squared. Now what do I have? Difference of 2 squares, right? 2 terms that are both squared. So, by difference of 2 squares, it's a plus b, a minus b, correct? Here's my a term. A plus b, which is 5a. And then a minus b. And that would be factored the whole way then. Does that make sense? Okay, I would have had 2 more problems for you guys to try. I think we'll be all right. Look at your notes for that. There will be some homework on this. See you guys tomorrow.